Okay, I'm going to do a quick rundown of some of the basics for cabling up, ready to configure and test on these WTM 4100s. So they're going to be the same between both units. Right now this one's Lyman, this one's Rivia. You've got your primary power goes into your input down here, your input A, but your secondary power does not go to your secondary down here. This is actually a secondary power module that was added. So it goes up here to this. Then going across, these are your 10 gig SFP ports, these three. The first one is going to go to your WTM 4100 number 1, which is your vertical polarization. Your second one is going to go to your 4100 number 2, which is your horizontal polarization. The third one is going to be the multi-mode fiber for the traffic port to the CSR. Then over here we have our management. You cannot access the ODUs through these trunk ports that are aggregated together. You have to have an access port through the GE ones. So this one's going to go to management to the CSR for this chassis. This one's going to go to WTM number 1, and this one's going to go to WTM number 2. This one I currently have configured as a test port for the testers, and will get shut off. And then again, they're the same configuration down on the other radio. Now we're going to go up to the ODUs and show how these get configured. Now, the number one thing is to know that they come, each of these power plugs right here comes with a little jumper. And what it is it's that power plug there, and they come from the factory with this jumper, because with that jumper in, then you would run GE number 1 as your traffic on a PoE. So you can power this unit through power over Ethernet through GE1, which is not what we're doing here. So they come out and get saved, and then you get cabled 16 gauge wire into there. And then you're going to use GE1 is going to be your management port for the Ethernet cable, and SFP number 1 is where your 10 gigabit SFP is going to go for traffic. So that's how each of the radios are in this configuration. This is my primary, this is my secondary, so these are aggregated together. So this is your vertical polarization, this is your horizontal polarization. And in a A2C configuration with dual polarization and dual channels, you've got to have X-PIC cables. So they're marked in and out. These TNC cables are going to screw on. In is going to go to out down here, and out's going to go to in down here. These are 3 foot, I believe, maybe 1.5 meter. These are a little more than 3 foot. Regardless, they're not a lot, but there's some there. And in the boxes with each of these, you're going to get a little cold shrink. So these are going to get cold shrinked on, but you're going to want to make sure everything's good to go prior to cold shrinking that. So this is your weather connected access port for these radios. I have a link up right now on this. Now I can't green everything up because it's mad because it doesn't see this, because I don't have another set of transitions, nor do I have another attenuator anyways. So we can't fully set this up in a test scenario, which is why the lights are not fully green here and why there's no green light on here. So right now, this unit is transmitting to this unit and receiving, vice versa, through the two. So in here is where you have voltmeter leads, and you have a little button to go through some different options that the manual will talk about. And then you have a USB port that you're really not going to use. It can be used for a wireless adapter, and it can be used in an extreme scenario to load firmware or software or a config file, but very likely not going to happen. Now there's one thing you're going to need when we're working on these is a small pick or a very small screwdriver for not only that, but these have very small screws in them. So you need a very, very small flathead screwdriver to get them out because they're screwed in from the factory, and then to screw them back in so they don't fall out. So every unit's going to have XPIC cables in this configuration. It's going to have XPIC cables, and it's going to use SFP1 for traffic, and it's going to use GE1 for management. Now, depending on how those hybrid cables are, you may want to run SFP2 for a secondary fiber. If there's a secondary fiber in that hybrid cable, there is enough SFPs to do so. So I'm now going to see if I can pull this out to get behind it. Now the way these are configured back here is these plates come in a bag or in a box separate. There's a gasket in between there, and they are off-centered, or they're angled. So you put the gasket on, the round gasket, and then 4 screws out here to attach this to the plate. In this situation, then I have the adapter on that where the flex would go, down to the attenuator, out and back up, so that they can talk to each other without overdriving the receivers. But there's knockouts here where they're centered to come right off the back with the flex. And then there'll be 2 brackets, one like this and one up there to hold it onto the tower. And then there's 4 Allen screws that attach that ODU into this bracket, so that can come off fairly easy. It's a universal bracket made for a few different options of ODUs. And then definitely want to make sure everything's capped. Inside the boxes, there are a bunch of, so you've got these and these that are extras to make sure and seal everything up, that are also strain reliefs for the cables. And then here's the little cold strains. And then you have to be careful because every box comes with, see, these would be the 10 kilometers. So these are the single mode 10 kilometer SFPs for extended distances. These are the multi-mode, so 850 nanometer multi-mode to the router, and then you have the 2 kilometer single mode that we're using.